My dear students, welcome back to our channel. In this video, I will be explaining the BCA third semester subject Internet Protocols as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 2 first important short question is Datagram. A datagram is like a single packet of data that travels across a network independently. It is used by the Internet Protocol, IP, to send information from one computer to another. Think of it like sending letters through the post office. Each letter, datagram, has the receiver's address, and it may take different routes to reach the destination. Even if some letters go different ways, they all reach the receiver, where they are reassembled. Key features of a datagram. Independent, each datagram travels on its own. Unreliable, delivery is not guaranteed, some packets may get lost. Contains address, has source and destination IP addresses. Self-contained, carries both data and header information, like address, size, and sequence number. Example. You send a 1 megabyte file over the internet. IP breaks it into 10 small datagrams. Each datagram may travel a different route to reach the destination. Once all arrive, they are reassembled into the original file. Easy trick to remember. Datagram is equal to independent packet. Like letters in the mail, each packet knows where to go but can travel separately. This is why datagrams are the basic building blocks of IP communication, making the internet flexible and efficient. Next important short question is 2. Fragmentation. Fragmentation is the process of breaking a large IP packet into smaller pieces so it can travel across networks with smaller maximum transmission unit (MTU) sizes. This ensures that data can pass through different networks without getting lost. Think of it like sending a big parcel through the post office. If the parcel is too big for the delivery truck, you divide it into smaller boxes. Each box has the same address so the receiver can reassemble them into the original parcel. Key points. Done by the IP layer in networking. Each fragment has its own header but keeps info to reassemble the original packet. Helps data travel efficiently across different network types. Example. Suppose you want to send a 1500 byte packet over a network with MTU 500 bytes. IP divides it into 3 fragments of 500 bytes. Each fragment is sent separately. Receiver puts all fragments back together to get the original 1500 byte packet. Easy trick to remember. Fragmentation is equal to breaking big data smaller pieces. Like cutting a big pizza into slices so everyone can eat it easily. Fragmentation ensures that large messages can travel across networks safely and efficiently. Next important short question is 3. Checksum. A checksum is a simple method used in networking to detect errors in data while it is being sent over the network. It helps ensure that the data received is exactly the same as the data sent. Think of it like counting the number of pages in a book before sending it. If the receiver gets a book with missing pages, they know something went wrong. How checksum works? 1. The sender adds up all the numbers in the data using a special formula. 2. This total is called the checksum and is sent along with the data. 3. The receiver recalculates the checksum from the received data. 4. If the two checksums match, the data is correct. 5. If not, the receiver asks the sender to resend the data. Example. You send data 10101010 checksum is equal to 4, number of ones. Receiver gets 10101010 calculates checksum is equal to 4 OK. If received data is equal to 1,111,010 checksum is equal to 5 error detected. Easy trick to remember. Checksum is equal to data's safety check. Like double-checking your homework before submitting. This is why checksums are very important in IP and networking to avoid corrupted or lost data. Next important short question is 4. What is meant by proxy ARP? Proxy ARP. Proxy ARP is a technique where one device, usually a router, answers ARP requests on behalf of another device that is on a different network. This allows devices to communicate as if they are on the same network, even if they are not. Think of it like a friend answering the door for someone else. The visitor thinks they reached the person directly, but the friend passes the message along. How proxy ARP works? 1. A computer wants to send data to another IP on a different network. 2. It sends an ARP request to find the MAC address. 3. The router responds with its own MAC address instead of the actual device. 4. The router forwards the data to the correct destination. Example: PC1 192.168.1.10 wants to communicate with PC2 192.168.2.20. Router R1 uses proxy ARP and replies with its own MAC for PC2. PC1 sends data to R1 which forwards it to PC2. Easy trick to remember. Proxy ARP is equal to acting as a middleman. Like a friend helping deliver a message when you can't reach someone directly. Proxy ARP is useful for simplifying communication between different networks without changing IP addresses. Next important short question is 5. Internet Control Message Protocol, ICMP. ICMP is a protocol used by IP networks to send error messages and operational information. It helps devices know if data has reached its destination or if there are problems along the way. Think of it like sending a return receipt or error note in the postal system. If a letter cannot be delivered, you get a note explaining why. Key functions of ICMP. Error reporting tells the sender if data cannot reach the destination. Query messages checks if a device is reachable or alive. Example: 1. You use the ping command to check a website. 2. Your computer sends an ICMP echo request. 3. The website responds with an ICMP echo reply. 4. If the website is down, ICMP sends an error message back. Easy trick to remember. ICMP is equal to Internet's messenger. Like a postman who also reports delivery issues. ICMP is essential for network troubleshooting, monitoring, and ensuring data travels safely across the Internet. Next Unit 2. Long questions. First important long question is 1. Internet Protocol, IP. The Internet Protocol, IP, is the main protocol in the Internet Protocol Suite, TCP/IP, that is responsible for addressing and delivering data packets from one device to another across networks. In simple words, IP is like the postal system of the Internet. It makes sure your data reaches the correct address. Key functions of IP. 1. Addressing. Every device on a network has a unique IP address, like a house address. This helps the network know where to send data. 2. Packetizing. IP breaks large data into smaller pieces called datagrams, so they can travel efficiently. 3. Routing. IP finds the best path for data to reach its destination, often passing through multiple routers. 4. Fragmentation. If a datagram is too big for a network, IP can split it into smaller fragments. 5. Delivery. IP delivers data to the correct device on the destination network. How IP works. Example. Imagine you want to send a file from your computer in Mumbai to a friend's computer in Delhi. 1. Your file is broken into datagrams. 2. Each datagram gets a header containing source and destination IP addresses. 3. Datagrams travel through multiple routers on the internet. 4. At the destination, all datagrams are reassembled into the original file. Even if some datagrams take different paths, IP ensures that the data arrives correctly. Types of IP. IPv4 uses 32-bit addresses, example, 192.168.1.1. Most common today. IPv6 uses 128-bit addresses, example, 2001 0db81, created because IPv4 addresses are running out. Easy trick to remember. IP is equal to Internet Postman. Breaks data sends to correct address finds best route delivers safely. IP is connectionless, doesn't guarantee delivery, but is the foundation of the Internet, enabling devices worldwide to communicate efficiently. Without IP, sending data across networks would be chaotic, just like trying to send letters without addresses. Next important long question is 2. ARP, Address Resolution Protocol. ARP stands for Address Resolution Protocol. It is used in networking to find the MAC address of a device when we know its IP address. In simple words, ARP is like a phone directory. If you know someone's name, IP address, ARP tells you their phone number, MAC address. Why ARP is needed? Computers communicate using MAC addresses at the data link layer. But we usually know the IP address, logical address. To send data on a local network, the sender must convert the IP address into a physical MAC address. This is where ARP comes in. How ARP works? Simple example. 1. PC1 wants to send data to PC2 on the same LAN. PC1 knows PC2's IP address, 192.168.1.5. 2. PC1 broadcasts an ARP request, who has 192.168.1.5. Tell me your MAC address. 3. PC2 replies with its MAC address, example, 001A to B, 3C, 4D, 5E. 4. PC1 stores this information in its ARP table for future use. Key features of ARP. Works only in local networks, LAN. Dynamic learns MAC addresses automatically. Fast maintains an ARP cache to avoid repeated requests. ARP packet structure. 1. Hardware type of network. Ethernet is equal to 1. 2. Protocol type, usually IPv4. 3. Hardware size and protocol size, length of MAC and IP addresses. 4. Operation code, request or reply. 5. Sender MAC and IP. 6. Target MAC and IP. Real-life analogy. Imagine sending a letter to your friend in an apartment. You know their name, IP address, but not their flat number, MAC address. You ask the building receptionist, ARP, who tells you the exact flat. Now your letter reaches the correct person. Easy trick to remember. ARP is equal to IP MAC. Converts logical addresses to physical addresses. ARP is a crucial protocol in networking because without it, devices would not know where to send data in a local network. It works quietly in the background to make communication smooth and efficient. Next important long question is 3. Packet format, IP packet. An IP packet is like a parcel used to send data across the internet. It carries both the data you want to send and the information needed to deliver it safely. Understanding the packet format helps us know how computers communicate efficiently. Structure of an IP packet. An IP packet has two main parts. 1. Header contains information about the packet and how it should be handled. 2. Data, payload, the actual information being sent, example, file, message, video. Header fields, simple explanation. Version shows the IP version, IPv4 or IPv6. Header length, size of the header itself. Type of service, 2S indicates priority, like urgent or normal. Total length, size of the whole packet, header plus data. Identification, flags, fragment offset, help in fragmentation and reassembly. Time to live, TTL prevents packets from circling endlessly, each router decreases TTL by 1. Protocol indicates whether the data is TCP, UDP, etc. Header checksum ensures error-free header. Source IP address, IP of the sender. Destination IP address, IP of the receiver. Options, optional extra features like security or routing instructions. Data payload. The payload is the actual message or file you want to send. It can be anything, a website page, email, or video clip. Example. Imagine sending a birthday gift to your friend. Header is equal to envelope information, sender, receiver, priority, instructions. Data is equal to gift inside, the actual message or item. Routers read the header to decide the best path, while the data remains untouched. Easy trick to remember. IP packet is equal to envelope plus letter. Header is equal to envelope details, addresses, instructions. Data is equal to letter inside your message. IP packet format is essential for internet communication as it ensures data reaches the correct destination safely and efficiently. Understanding this makes concepts like routing, fragmentation, and error checking easier to grasp. Next important long question is 4. Types of ICMP messages. ICMP, Internet Control Message Protocol, is used to send error messages and control information across networks. ICMP messages help devices know what's happening with the data being sent and are essential for troubleshooting network problems. There are two main types of ICMP messages. 1. Error reporting messages. These messages inform the sender when something goes wrong while delivering data. Common error messages. Destination unreachable, the receiver cannot be reached. Example, you try to visit a website that is down, ICMP tells your computer destination unreachable. Time exceeded, data took too long to reach the destination, TTL expired. Example, a packet keeps circulating in the network without reaching the destination. Redirect message tells the sender to use a better route. Purpose ensures that the sender knows about delivery problems and can take action. 2. Query messages. These are used to check the status of devices or request information. Common query messages. Echo request, echo reply, used by the ping command. Example, you ping google.com. Your computer sends an echo request, Google responds with an echo reply. This tells you the server is alive. Timestamp request reply helps measure delays in the network. Purpose helps diagnose and monitor the network efficiently. Real-life analogy. Error messages is equal to postman telling you the mail cannot be delivered. Query messages is equal to asking the post office if a letter has reached your friend. Easy trick to remember. ICMP is equal to Internet's messenger. Error reporting is equal to something went wrong. Query is equal to are you there? ICMP messages are not used to carry user data but are vital for network health. Tools like Ping and Traceroute use ICMP to check connectivity and identify where problems occur in the network. In short, ICMP ensures that the Internet runs smoothly by reporting errors and providing status information. Next important long question is 5. Advantages and disadvantages of IGMP. IGMP, Internet Group Management Protocol, is used by devices on an IP network to join or leave multicast groups. Multicast allows one sender to transmit data to many receivers at once, like streaming a live lecture to multiple students without sending separate copies to each. Advantages of IGMP. 1. Efficient data delivery. Saves bandwidth by sending a single stream of data to multiple receivers instead of separate streams. Example, a live cricket match streaming to 1000 viewers uses one multicast stream, not 1000 separate streams. 2. Dynamic membership management. Devices can join or leave multicast groups anytime without affecting others. Example, a student joins a live online class halfway, IGMP ensures they start receiving the stream immediately. 3. Supports large networks. Works well in LANs and WANs, allowing group communication across networks. 4. Reduces network load. Unlike broadcast, multicast with IGMP only reaches subscribed members, reducing unnecessary traffic. Disadvantages of IGMP. 1. Complexity in configuration. Requires routers and switches to support multicast routing, which can be complex in large networks. 2. Security concerns. Unauthorized devices may join multicast groups, potentially receiving sensitive data. 3. Limited to IPv4, IGMP v2.3. For IPv6, a different protocol called MLD, multicast listener discovery, is used. 4. Not always supported everywhere. Some older devices or network equipment may not handle IGMP properly, causing packet loss or delays. Real-life analogy. Think of IGMP like a TV cable system. Only subscribers, group members, receive channels they pay for. You don't broadcast the same channel to every house unnecessarily, saving resources. Easy trick to remember. IGMP is equal to group party protocol. Join is equal to you get the invite. Leave is equal to you stop receiving updates. Sends one message to many friends efficiently. IGMP is crucial for multimedia streaming, online lectures, and gaming, making group communication fast and network friendly, but it requires careful configuration and management.